Welcome back. In this section, we are going to start the hands-on of the machine learning part for our project core. In the previous section, we got the math side of the equation. We looked into how the error is minimized and how the conversion process happens in the math side as well, and also in the graphical format. If you have any more questions, then you can use the discuss forum to reach, because it's just the initial click. Once you understand how it works, what is the mindset used to iterate and reach to a model which then can be referred, then you would be easily able to understand other machine learning models as well which are out there and the algorithm. Now in this section, I would be telling you what are the steps which we are going to perform when we go in the hands-on in the Spark. You can also perform the same thing with Python. There are libraries or the algorithm which we come up with. It's not very difficult algorithm to implement in the coding level from your own side. You need to just have some of the libraries helping you in the dot products or the matrix multiplication. That's the only part for which you might need libraries, and apart from that, other equations can be taken care of by just the Python program. But we are going with Spark because when the data set becomes large, very large, then we need to have a distributed environment running it. So based on the data, it can scale easily. And Spark mlib is one of the library which is prominently used now for that purpose, and we will be looking and working with this library. Initially, we will have a cluster in our Google Cloud Platform, which is GCP for short, and we would be creating a data proc, and data proc will be internally giving you some of the nodes which will have Hadoop Spark on it, and you need to just tell how many nodes we need to create. This cluster will be available to you. There will be one master node and other would be the slave node to do computation. Now, from the local machine, we will be doing SSH. We are doing SSH because in the previous sprint, we have the product rater file from the previous section, which contains the co-product, initially what we have, which we did in the previous sprints, and we will be loading this data directly into HDFS of GCP. So this is the Hadoop distributed file system, and we will be doing this to the master, and master then will be taking care of distributing it along all the slaves node as well. So pretty simple step. Why we are doing it? Why we are not directly loading the data to Spark? Because we need to save the model back to HDFS as well, and we are taking care when the data becomes very large. So this use case is prominently thinking or taking care of the matter that the product rater file can be huge, and when you go to enterprise, this file might need to be also stored in multiple systems. So your availability is high, you are taking persistency storage into consideration, and HDFS is a cost-effective format now enterprise are using, and we just want to showcase how the complexity will be when we try to take care of scale into consideration, your persistency storage into consideration, and do it with some of the existing tool in a workflow. You can directly use this file because this file will be about 200 to 300 megabytes, so not a very large file. If this file is in gigabytes, then still our workflow will be valid. But at this point, you can directly load this file into Spark, but we would be following the difficult route, doing it in HDFS, so you understand how to work with that as well, which we have covered in the previous section, the basics about. Now, once we have the HDFS here, then we would be loading the data into the Spark. We will be calling the Spark context, and we will be loading this file, and this would be a text file. And this text file, when it will be loaded in the Spark context, the Spark context will be then utilizing the RDD to transform and load the data into RDD. Now, once we have the RDD form, we will not be using RDD to run ALS. We can do actually. RDD is a structure in which Spark stores the data, and this structure then can be used by our machine learning algorithm within Spark and do the machine learning model and computation. But we will not be using RDD because from a performance aspect, data frame is much better. Data frame in the previous section, as we discussed, is a special type of RDD, resilient distributed data set, and data frame, also denoted by DF, is a special type of RDD. And this RDD, to give you an example, if we run the computation with the RDD on a single core Spark, then we have also taken 5 days to come up with a model, machine learning model. But when we ran with the data frame, the same data set, it took about less than 1 hour, maybe half an hour, or sometime less if you are running with 3 cluster slave and 1 master. So performance drastically improve when you use data frames to do heavy computation operation. Now, more about what is the difference in the architecture is already covered, so I'm not going in the details. Once we have the data frame containing the text file data, then I will be splitting the data set into training and test data. So there will be certain amount of data, most likely 80 to 20% data will be split. 80% would be utilized for the training and 20% will be utilized for testing. So the same sample data will be split. The first will be training data set and the second will be the testing data set. You can have this split into 90 to 10% as well. If you have a data set, you can split the 90% of the part as a training data set, which would be utilized in the training of the model, and 10% for testing of the model if the model which we got is correct, validating the model in a way. Now the next thing we would be doing is we would be training the data set and acquire the model. Now this model out here would be basically a large two-dimensional matrix. As in the maths we have seen the product and the user, so this will be a large matrix and where the rows and columns will be in millions. Now this model will be validated with the test data in the next step, but this model will be basically what we are after. We will be using the Spark mlib library, and inside the mlib we have a module called ALS, alternative least square, which would be utilized to fit the training data and the test data and all the parameters. So we'll be fitting all the parameters and we'll start training the data set to create the model. Once we got the model, we will be evaluating the model and seeing if the final output, what we are getting in form of model, has a good amount of accuracy to guess what is present in the test data. So test data would be like product 1, product 2, and their probability of being co-product. And the model will have some value, maybe V1, and in test data there will be some value, let's assume VT. So we will be checking if VT is very close to V1 and how much error we have, and all those things will be taken care when we do a validation of the model with the test data. Now once we have got the model, we will be actually saving the model, because this model is what we will be using in future. This is the output for the machine learning, this model. We will be referring to this model anytime a query comes, and this model will be referred to see what is the probability of two products being a co-product, and this is the model which is already been trained. And sometimes what happens that the model in the production environment keeps on getting trained from the past experience or the current experience which is happening. If it has guessed something and it doesn't guess has happened, then the model get trained, and that is continuous training for a model, and it makes the model much better. For our case, we are not considering the scenario of continuous training. We are just having this model which is learning from the past sales data. Once we have that model, we are just referring to it when we have a query for two products, if they are co-product or not. So this two product query will be coming through APIs, and these APIs then will be processed by our model with the Python program, and the Python program will be then giving back what is the probability of both of them being a co-product. So till now, we have 8 steps to train our model and save our model into memory. So these are all the steps which concern about the machine learning part of the project code. So let's go in the Google Cloud Platform and perform all the steps one by one.